Hello class, this is Mrs. Albritton of Albritton's Math Class, AMC. So this video is the study guide for the first unit test for AMDM. Well, we were taking a look at estimating crowds and estimating volume. So this is the handout that you have to help you prepare for the test. Let's take a look at the problems. So for number one, John has 3 times as much money as Tom. What is the ratio of John's money to the sum of money for both John and Tom? Well, we're just looking for a simple ratio here, and notice that the ratio choices are written with a colon in the middle. That's one way to write a ratio. You can write it as 2 numbers with a colon separating them. You can write it in fraction form, and you can write it using the word 2, like 1 to 3. Well, they tell us that John has 3 times as much money as Tom. So say, for example, if Tom has $5, John has 3 times that, which would be 15. If Tom has $20, then John would have $60. So that means John's amount is 3 times whatever Tom has. Now that's for the first part of the ratio. The second part is gonna be the sum. So sum means that you're adding up. So it says the sum of money for both John and Tom. So if Tom has 1 of some amount and John has 3 times that amount, then the sum or the total is 4. 1 plus 3 is 4. So we're looking for something with a 4 in it. There's 2 of them with a 4 in it, C and D. And again, we have to look at how they want us to write it. So it says that they're looking for the ratio starting with John to both of them. So both of them is 4 when we total it, and John's is 3. That means we're looking for this ratio, 3 to 4. So the answer is C for number 1. Number 2, we're asked to find x if x over 7 is equal to 3x plus 20 over 35. So here we have a proportion. How do I know? Because I have a ratio set equal to another ratio. And the way we solve proportions is we just cross multiply. Once we do that with these expressions in here, we're gonna end up with an equation that we can solve for the variable x. So when I cross multiply x times 35, I have 35x. And then 7 times 3x plus 20, I actually have to do that calculation. So I've got to apply the distributive property to this cross multiplication so I can get the expression that I need. So 7 times 3, that gives me 21x, because there's an x with it. 7 times 20, that gives me 140. So this expression is the second part of our equation. So I'm gonna write 21x plus 140. And then I've gotta solve this. So let me write it over here so we'll have more space to work on that. 35x equals 21x plus 140. All right, so the first thing you know you gotta do is get your x terms together. They're on opposite sides of the equal sign right now, and we can't have them separated because they're like terms. So what I'm gonna do is I'm going to move the 21x from the right side to the left side. How do I do that mathematically? I use inverse operations. And since this is 21x, I need the opposite of 21x, which is a negative 21x. So if I put a negative 21x underneath this one, I've got to, whatever we do to one side of the equal sign for an equation, see how I did this? I just added this to the right-hand side. I've got to put it on the left-hand side also. That's how you solve any equation. You have to keep them balanced and actually do the same thing to both sides. So I got to put a negative 21x on the left side also. And what happens is opposites cancel each other out. They go to 0. And then when I work this out, I'm going to end up with 14x, because 35 minus 21 is 14, and they are x terms. And it equals what's left over on this right-hand side. And the only thing left, since this has canceled out, is 140. So I bring that down. And now I've got to solve for x. When you solve for a variable, that means get the x by itself, get the variable alone. So you're isolating that variable. And in order to do that, since this is 14 times x, inverse operation of times is divide. So I divide by whatever I'm trying to eliminate, which is the coefficient 14. I don't want to get rid of the x, I want to keep the x so I can solve for that variable and find out what x is equal to. Again, whatever you do to one side of the equal sign, you've got to do to the other, because these are equations, they have to stay balanced at all times. So this cancels because 14 divided by 14 is 1, and 1 times x is just x. So we have eliminated the coefficient, x is left, and when I divide 140 by 14, I get 10. So in this case, the answer is also C. Number 3. The number of students studying physics in a university is 20%. If 12,000 students are not enrolled in physics, what is the total number of students in the university? Now for this problem, let's look at that percentage that they give us. We have 20% of the students taking physics. And then it says that if there's 12,000 students not in physics, what's the total number of students in the university? So what we have here is, let's think about the fact that there's 100% of whatever their enrollment is in the school. We have 20% taking physics. Well, that means that 80% are not taking physics. Does that make sense? Because 20%, 80%, that's your 100%. So what I want to write here is that 80% are not taking physics. And that was, that's an assumption that I can make. Because if 20% are taking it, I can assume that the other 80% are not. But then they give us the total number of students. It says if 12,000 students are not in physics, what's the total number of students in the university? So what I'm gonna write here is, we have deduced from this information is that 80% of some total amount of students, I'm gonna let X be the total number of students in that school, because that's what we're trying to find. We wanna know what is the total number of students. So let's let X be that total number. So 80% of the total number of students are not taking physics. Remember, if 20 are taking it, 80% are not. And then it says 12,000 are not. So 80% of some amount is gonna be those 12,000 students that are not taking physics. Now, this is what I'm trying to find. How many kids are in that school? Or how many young adults are in that school? And we know that, so whatever that amount is, it's gonna be 80% of this. So these are not taking physics. So hopefully that makes sense to you. Now, before I actually work this out, a couple things I gotta do. I need to recognize that in math, the word of represents multiplication. So it's 80% times whatever this amount is. And secondly, I've got to change that percent to a decimal in order to work with it. So let's do that. The way this is gonna be written is, instead of 80%, I'm gonna put 0.80. Or I could just put 0.8. You really don't need the 0 at the end if it's at the end. But so I just wanted you to see that I've changed the percent to a decimal. So 0.80 times X. Because remember, the word of means X, means multiplication. So 0.80 times X is equal to 12,000 students. Okay, 80% of the total amount of students is 12,000. Now I need to just solve it. This is just a one-step equation now. So what I'm gonna do is, because remember we wanna get the variable by itself. So I've got to divide 0.80 on both sides. And once I do that, these are gonna cancel out, and then my X is gonna be equal to, when I do this work, if you put this in the calculator, 12,000 divided by 0.80, you're gonna get 15,000. So that means that this school has 15,000 students, okay? And then number 4, let's solve for X. So we've got another solve for X, which is similar to this one. They give us a proportion. Here's a ratio set equal to another ratio. So we're just gonna cross multiply and we're gonna solve it. Okay, when I cross multiply, I get 2 times 45 is 90. And then I've got to do 9 times this expression. Now that's 9 times 7x is 63x. 9 times -4 is a negative or minus 36. So this is the equation that we have ascertained from number 4. So let's solve for x, because that's what we're trying to find. Since this is a two-step equation, the first thing I want to get rid of is my constant. A constant is a number that does not have a variable with it. Since it's a minus 36, I need to do the inverse of that, which is a plus 36. Of course, whatever you do to one side of the equal sign, you have to do to the other. So I need to come over to the left side and put a plus 36 also. And what that does is it cancels these because opposites cancel out to 0. And I bring down everything that's left. So I've got 63x still over on the left-hand side, and then I've got 126 over on the right-hand side. But I still don't have the x isolated because that 63 is there. So how do I fix that? The inverse of 63 times x is divide by 63. So these will cancel. Don't forget, whatever you do to one side, you do to the other. And this 126 divided by 63 is 2. So x equals 2 for problem number 4, and that is B. Okay? Now we're going to take a look at number 5 and 6. Number 5, 4 ounces of raw potatoes unpeeled contains 87 calories. If a goat consumed 3 pounds of such potatoes, how many calories did the goat gain? So let's look at the proportion that we have. Here we're going to set up a proportion and solve it. The first ratio that I notice is that we are given that there's 4 ounces of raw potatoes contains 87 calories. Now that means that when we set up our second ratio, we want to be consistent and stay with ounces on top and calories on bottom. So what are we given? Well, we're given that they consume 3 pounds. And there's another issue here. So we have ounces and pounds, and we need to have the same unit. Since we've got 4 ounces, let's actually convert 3 pounds into ounces. And I think most of you know that 1 ounce does equal 1 pound equals 16 ounces. So 16 ounces is 1 pound. So let's use this information. So it means that 3 pounds would be 48 ounces. And then we don't know how many calories. So this is the unknown, and this is our proportion. Let's go ahead and cross multiply. We get 4 times x is 4x, and 87 times 48 is 4,176. Okay, I already did the math a little earlier. So now let's go ahead and solve for x. Let's divide both sides by 4. And then x is going to equal to 1,044. So that is B. Number 6. So we've got a crowd that's 700 yards long along a parade route. It's 9 feet deep on both sides of the route. So the first thing I notice is both sides. So that tells me something, that I'm going to have to double my answer at the end. But we've got a 700-yard long crowd, but then we've got 9 feet. So we see different units. We've got to convert so we can have consistent units. Assume that the route is a straight road. What's the total area covered by the crowd? So what we're going to do here is, in this case, let's see, we can either change yards to feet or feet to yards. So, and I see that, I think most of us know that there are 3 feet in 1 yard. So we could change 9 feet into 3 yards if we like. So let's do 3 yards. Because we do that, it'll match the 700 yards. So let's see how that works out. And we could also do the other way around. We can change 700 yards into feet to match the 9 feet. So let's go ahead and set up our proportion so we can solve it here. Oh, I'm sorry, we don't even need a proportion because all they want to know is the area. Let's do that. So we've got, let's do 700. Remember, area is length times width. So we got 700 yards. and we would multiply that by 3 yards, which would give us 2,100, because 3 times 7 is 21 and the 2 zeros, yards. All right, now if you notice, the answers are in feet. So I need to remember though that I've got 2 sides of the street, so I need to double this amount, which is 4,200 yards. But let's convert this to feet. So 4,200 yards, since 1 yard is 3 feet, 4,200 yards is 4,200 times 3, which would be 1,200, 600. All right, but if you notice, we've got 1,200, 600 feet squared and 12,600 feet just by itself. So I see the same number, but I see the unit is slightly different. Do you notice it? This is feet squared, and this is just feet. Now, which one matches area? The square foot does. So this will be the answer that we're gonna use here. Be careful, the units does matter, okay? All right, let's take a look at the rest of the study guide.